This says set up an integral to find this area and use a calculator to evaluate it. So the area we're looking at is this little bit down here, and we're looking at r equals 1 plus sine theta. So I'm going to come over here and I'm going to graph this in Cartesian. Y equals 1 plus sine x. But really my x here is the same as my theta, and my y here is the same as my r on the polar graph. So if I graph this rectangular, it's just the sine graph shifted up one. So here's pi and here's 2 pi. So we're going to have a point here, here, and here, here, and here. So let's look at let's look at how the different parts of this graph correspond to the parts of this graph. All right, this point has let's see, its x coordinate is 0 and its y coordinate is 1. So over here, this is our angle of 0. This is our angle up here of pi over 2. So this purple point corresponds to this point right here, where the angle is 0 and the radius, the distance from the origin, is 1. Now, if this purple point up here, the angle, well, over here, the x coordinate is pi over 2, and the y coordinate is 2. If we come over here, that's this point here, where the angle is pi over 2, and the radius is 2. So that's the distance down there. So this purple bit of the curve corresponds to this. Now this next bit I'm going to do in green. That goes from pi over 2 to this point, which is pi 1. That's right here. The angle pi and the distance 1 from the origin. And it's this next bit that we're really interested in. This is where we go from pi 1 down to, let me do that in a color. I thought I had blue there. Down to here, which is, what is this, 3 pi over 2? And the y coordinate there is 0. So that's this bit right here. So it's that blue bit that we want to integrate along. So our integral is going to, for area, is going to be 1/2 integral from pi to 3 pi over 2 of our function 1 plus sine x quantity squared dx. Now this actually wouldn't be a terrible integral to do by hand, because once you square this out, you get 1 plus 2 sine x plus sine squared x. And the sine squared you can deal with an identity. Wouldn't be that much trouble, but still maybe not something we really want to do. So let's just evaluate this using a calculator. So I'm going to enter in here 1/2 integral, bring my keyboard over here in front of me, integral from pi to 3 pi over 2, 1 plus sine x. I guess that should technically be a theta instead of an x. Doesn't really matter as far as plugging it in, but let's keep it right. 1 plus sine theta quantity squared d theta, and it gives me that 0.178 something. .178. We'll just round it there. We'll use a squiggly equal.